Now in the previous video, we added new machine and material files to the iDatabase, and we defined the parameters that are required by the iMachining technology. In this particular video, we're going to do a few things. Just like we've been doing, we'll start a new CAM project and define the CAMPart. Then we'll add the first iMachining operation to start the programming. And during this process, I'll show you two different ways that the iMachining data can be defined for the CAM project. And finally, we'll define the rough and finish machining of the outside contour using the iRough and iFinish technology types in iMachining. Alright, so here we have our part ready to go into SolidCAM for programming. To start our new CAM project, let's go to the SOLIDWORKS main menu and click SolidCAM, New, Milling. When the new milling part dialog box opens, we can review how and where our CAM part will be created. Based on our CAM settings defaults that we selected in the previous exercise, we will create the CAM part via the external mode. We'll again save the CAM part in the model file directory by default, and we can click OK to confirm the CAM part definition. Now when the milling part data dialog box appears, we can define the CAM part. We'll want to keep our default controller selection in order to post G-code for a 3-axis Haas-SS. Moving down to the next section, let's define the coordinate system or home position for all our iMachining operations. To start the coordinate system definition, go ahead and click the Define button. Using the default selections, click on either the top face of the stock model or target model in the SolidWorks graphics area. This will position the coordinate system on the model with the z-axis perpendicular to the picked face. In the Pick section, let's now enable the Pick Origin option and pick the back left corner of the stock model. We can click OK to confirm our coordinate system positioning, and we can click OK again to accept the default machining levels. Our coordinate system, Mach 1, Position 1, is created, and now we can confirm its definition by clicking OK. Next up, we have to define our stock and target models. In the Stock and Target Model section, first click the Stock button to start the stock model definition. Once the model dialog box appears, click the drop-down in the Defined By section and choose 3D Model from the list. Now we can simply just pick on the model representing our stock material in the SolidWorks graphics area, and then click OK to confirm the definition. Let's follow a similar method for defining the target model. First, click the Target button. This time, after the model dialog box appears, we can just go ahead and pick on the solid representing our target model. The solid is highlighted in the SolidWorks graphics area, and we can now click OK to confirm the target model definition. There's one more thing we can do in the CAMPart definition to prepare for using the iMachining technology. If you click the drop-downs under the Machine Database or Material Database, the lists will show the machines and materials that are currently on the system, either included or ones that we added. So you'll see that our Haas-SS new machine is listed, as well as our aluminum 6061 T6 material option. Now, I don't want you to make these selections just yet, so click outside of the drop-downs. Click the Edit iMachining Database button for just a minute. This will display the iDatabase dialog box, which you just saw in the previous video. This is another way to access it, where you can again add new and edit existing machine and material files in the iMachining database. Click the Cancel button to exit the iDatabase dialog box. Now, let's say that we don't define the iMachining data right now. What will happen? Well, let's see. Click OK to complete the CAMPart definition. The Milling Part Data dialog box closes, and the SolidCAM Manager appears in the SolidWorks Manager pane. Now, let's go ahead and get started with the programming of this part. First, we should use iMachining to define the rough and finish machining of the outside contour. Now, in some cases, like we did in the previous exercise, it is certainly possible to use iFinish directly after iRough. This again happens to be one of those instances where we can do that. Once we define the machining on the inside of this pocket, however, we'll have to use the iRest technology type. I'll get into that later, but for now, we can just get away with roughing and then finishing. So let's add the first iMachining operation by going to the SolidCAM Manager on the left. Right-click Operations, Add Milling Operation, and select 2D iMachining. Now, because we did not define the machine and work material that we'll be using in the CAMPart definition, the iMachining technology prompts us to make those selections now. These selections are required in order for the technology wizard to output the optimal cutting conditions. First, we must define the machine. So choose Haas SS New from the list and then click Next. Now, we have to define the material. Let's obviously choose the one that we added, aluminum 6061 T6. It's here that we can also add new as well as edit existing iMachining database definitions during this selection process. Now, when we click the Finish button, a few things happen. iMachining is informed of the machine and work material parameters, and the iMachining operation dialog box is displayed. In addition, the iMachining data is automatically populated and saved in the CAMPart definition. Let's now get started with the operation definition. As a recap of the previous exercise, we're going to perform only the minimum requirements that are needed to define this iMachining operation. So again, what does that involve? Well, it involves us first defining the geometry, and then the tool and the levels. So on the geometry page, click the New button to define the machining geometry. For this operation, the geometry is defined as an open pocket with island. We first have to select the outer chain, followed by the inner chain. In the SolidWorks graphics area, pick on the lower contour of the stock model to start the chain and then use Auto Constant Z to close it. When prompted, click Yes to accept the chain selection. Then, pick on the lower contour of the target model to make the initial inner chain selection. Use Auto Constant Z to close the chain, and then click Yes to accept the chain selection. In the chain list, right-click Chain 1 and choose Mark Chain as Open. Now iMachining is informed to start machining from this outer chain. Let's now go ahead and click OK to confirm the geometry definition. Next, move down to the Tool page and click the Select button to start the tool definition. The part tool table is empty, so of course we'll have to define some new tools for this CAM project. For this particular operation, let's first add an end mill and then define the following parameters. Set the diameter to 12 millimeters and change the number of flutes to 4. Let's leave the remaining default values. I'll talk to you about what parameters specifically affect iMachining in more detail later. For now, we can confirm the tool definition and choose the tool for the operation by clicking the Select button. Finally, we can switch to the Levels page to pick the milling levels directly on the model. To define the upper level, first click the button and then pick on the top face of the stock model. Click OK to accept the selection. Next, click the Pocket Depth button and pick on the bottom edge of the target model to define the machining depth. Then click OK to accept the selection. Let's also enter a delta depth so that we can perform the machining a little deeper than the part bottom edge. I normally like to set this value to negative 0.76 millimeters. Now that's it. Those were the minimum requirements for defining an iMachining operation. On the Technology Wizard page, we can see what iMachining has calculated for the cutting conditions based on the geometry, tool, and levels definitions, plus the machine and work material parameters. We can now click Save and Calculate to add this iRough operation to the CAM tree and calculate the iMachining toolpath. Then, click Simulate to open up the simulation control panel. We'll use the default HostCAD mode along with some of the same options that we used in the previous exercise, including the Show Trail, Show Tool 3D, and Solid Verification options. By clicking Play, we should see the tool perform the machining of the entire outside contour with an allowance of 0.24 millimeters left on the walls, which is the default offset value for an iRough operation. Let's now define the finishing to remove that offset. First, click the Exit button to close the Simulation Control Panel, and when the iMachining Operation dialog box reappears, simply click the Save and Copy button. A copy of the current operation will be created and will have the same geometry, tool, and levels definitions. All we have to do is click the Technology dropdown in the upper left corner and choose iFinish. We can now click Save and Calculate to add this iFinish operation to the CAM tree and calculate the iMachining toolpath. Click the Simulate button. Set your desired speed and then click the Play button. We'll see now that the offset left from the previous iRough operation is removed with a single pass. Let's now finish up Part 2 by closing the Simulation Control Panel and the iMachining Operation dialog boxes with the Exit buttons. That quickly and that easily, we not only started a new CAM project and defined the CAMPart, but we also just defined the rough and finished machining of the outside contour using the iMachining technology. In the next video, we'll start an iMachining operation definition to machine out the majority material inside this pocket. We'll make the geometry, tool, and levels definitions just like we've been doing. This time, however, when we reach the Technology Wizard page, I'll explain what it does and how it can be used a little bit more in depth. You won't want to miss it.